Hello, my name is Leo. Welcome to the second part where we talk more about coplanar vectors. First, we have vector multiplication by a real number. Here are some properties of this kind of multiplication. First property says us if we multiply vector by 1, then we get the same vector. Next three properties say us about characteristics of this kind of multiplication, similar to the normal distribution to the normal multiplication distribution property. And the last property says us if we multiply absolute value of a real number x times length of a vector, it's the same as absolute value of x times a, vector a. Here we have example of three vectors where a and b are equal vectors, and c is minus 1/2 of a, also minus 1/2 of b, so k, which is the real number we multiplied by, is equal to minus 1/2. Linear dependence of vectors is dependence that can be expressed via this general form, where vector v is a linear combination of vectors a and b, which are multiplied with their coefficients k and l. Linearly dependent vectors are those vectors which are collinear, meaning that they have the same direction and can be expressed by each other via this formula. Here we have example of two vectors a and b and two cases of vector v. In first case, vector v is a sum of a plus b, and in the second case it's 2 times of difference a minus b. So vector v is a linear combination of a and b. Scalar product of vectors is product of some vectors, for example a and b, which is calculated via this formula. Angle phi is angle between these two vectors, for example OA and OB, and it's important to say that these two vectors have to have the same tail point. Here is point O. And cosinus of phi is calculated via this formula, which is derived from the basic formula for the scalar product. There are two special cases of scalar product, collinear and parallel vectors, which are actually vectors which have angle of phi equal to 0, so cosinus of 0 is equal to 1, and their scalar product is actually product of their lengths. And perpendicular vectors which have angle phi of 90 degrees, cosinus of 90 is equal to 0, so their scalar product is also 0. Vector projection is an orthogonal projection of some vector OA onto another vector OB, or a straight line which is parallel to OB, and this projection we mark as OA with apostrophe. And it's important to say that OB must not be a null vector. Now we have to define a unit vector, which is a proportion of a vector and its length. In the first formula is projection of vector b onto vector a. We calculate via this formula, where it is also included this unit vector. And the second formula says us about length of this projection. Now, orientation of this projection vector, projection of b onto a, depends on angle phi. If angle phi is acute, meaning that it's smaller than 90 degrees, then it has the same orientation as a. If phi is obtuse, so bigger than 90 degrees, and smaller than 180, then it has opposite orientation of vector A. And if angle phi is equal to 90 degrees, so right angle, then projection is actually null vector, meaning that it has no orientation. Thanks for watching. I hope you've enjoyed this video and that you've learned more about coplanar vectors. And stay with us.